by a few physicists. So it has really come out, the contribution have come out following, standard procedures. So nobody really can say that this is a seance of true believers or whatever. It's just people who are willing to stick their neck out on what they say. They believe it's true. That doesn't mean that they are right. I think this hysteria with making mistakes is something which is most obnoxious and in fact contrary to the interest of science. Science thrives on mistakes because scientific progress really consists of making mistakes and correcting them. That's exactly what it is. Not recent history, but the history of science, to see how the people who were so attached into thinking about the Ptolemaic system accepted the new Copernicans, and in fact how they sent Giordano Bruno to the stake and Galileo almost to the stake, but then took the confinement the last 10 years, 15 years of his life, of his fantastic life, but a very sad end. Those were the people who were righteous and convinced that they ought to stop the nonsense of the Copernican heliocentric view of the world. And in a way, in a way, some of the people are behaving, in these days, they're really going through a well-known pattern. And I think, presumably, just following what a philosopher said, people who don't know the history are condemned to repeat it. Presumably, that's the problem. So the content of this book has a certain number of highlights. There are certainly the experiment by Melvin Miles and collaborators at China Lake, at the Naval Lab of China Lake, California, who, with Ben Bush, Lagosky, who show that the cells that give out excess heat with a rate which is comparable with what Fleischmann, with the rate that was given in the early announcement of Fleischmann and Pons, when analyzed, when one looked at the gases evolved out of the electrolytic cell that gave excess heat, one would find a quantity of helium-4 which was commensurable with the quantity of excess heat, in the sense that if we believe that each diffusion gives off a helium, about 24 MeV of heat and helium-4, then you find out you can count the number of helium-4 which you expect for a certain for the production of a certain amount of heat, and you find the essential thing. And he has about 10 cells that have done that, and he finds helium in all of this, and then he has blanks, meaning cells which work with light water or what have you, or with the palladium or platinum electrodes, the cathode instead of palladium, or the one who simply do not give excess heat, because we know that the one that should give excess heat. Now, this is another point. Then it doesn't find anything. So the probability that what Miles finds is an artifact is very low. It's the order 10 to the minus 4 or something like that, being the artifact. And that, I think, is a very, this is a very significant contribution. This has been published in a well-respected scientific journal, like the Journal of Electroanalytical Chemistry, and the scientific community, the ones who are very much against all this phenomena, have taken no notice of it, nor have they deemed it important and reasonable to change up their mind, nor have they deemed important and interesting to challenge the result. The whole thing has been just left in total, but has been ignored, essentially. So this is one thing. The other thing is the results of Mike McCubrey, who Mike McCubrey, I will recall to you, is the leader of the lab where recently, at the beginning of the year, a very tragic accident occurred, taking the life of a young researcher, Andy Riley. It is interesting, parenthetically, that after more than 3 months of that, essentially a tragedy, a scientific tragedy, there's still no report made as to what the causes of that explosion were. And I myself, having talked to some of the people who were involved in it, have made a good conviction that that explosion occurred was due to runaway of the nuclear type that Flashman and Pons had already warned against in their original paper in the Journal of Electroanalytical Chemistry. So Mike McCubrey at Como presented the results of his group. By the way, Mike McCubrey is the one who's going to receive, according to a recent release that appeared in press release that appeared in the Wall Street Journal. He's the recipient of a grant of $12 million in 3 years for research on cold fusion, financed by EPRI. He presented a very sophisticated calorimetric analysis of a certain experiment of the Flashman-Pons type and concluded that he had foolproof evidence that there were power releases in the order of 10 watts per cubic centimeter of palladium of excess heat, and he also made a very systematic analysis as to what the condition of loading for the experiment we were successful were. And he concluded that the condition of loading were such that the ratio D over PD should be close to 1 in order of the number of the deuterons of a palladium atom should be close to 1 in order for the nuclear events, the nuclear fusion events to take place. This is the most direct experimental analysis and findings, because it would give a completely rational explanation of all reported negative results. So far that the people who find negative results are not able to show evidence that they were able to appropriately load the electrodes of their electrolytical system, no reason should be found whatsoever that they should get positive results. And a very important conclusion in the panel of the conference on Como came out, really to that effect, that we are not going to accept negative evidence if what appears to be a necessary, even though not yet sufficient condition for getting a result are not met. I will also mention the results by Stan Pons, who shows the result of a series of experiments that he conducted both in Utah and in his new lab where he's working now in Nice, where with palladium alloys, with electrodes of palladium alloys with silver, he can really get to very high power densities on the order of a kilowatts per centimeter cube.